Don't make them up. Hi you guys, it's Mrs. Rona. We are going to go ahead and demonstrate the horizontal projectile lab for you all. Part 1 is to go and run the ball 3 trials. You want to get the time for each trial at the same angle. We've already placed the ruler out here for you so you can make a measurement. If you look from when the ball hits the ground to the end of the table, that is the measurement. Okay, make sure that you make conversions. Okay, we don't have 92 meters. It's something less than that. Figure that out because that's going to be your delta X. So I'm going to go ahead and let the ball roll, and I'm going to go ahead and get the time using my cell phone. So I'll be taking the time from when it hits the ground to when it ends the table. Okay, first run, here's the time, 0.75 seconds. The ball, going for round 2. Same thing once again. You're gonna let the ball go. Next time was 0.90 seconds. That's really off. All right, third attempt. Try that again because I pressed the button at the wrong time. All right, 0.8. All right, so those are the 3 times for the very first trial at this angle. Next, what I'm going to do is I'm going to get the height of the table. Oops, sorry. Record that on your data table. This is the delta Y. Now every trial I'm going to run at the same exact height of the table, so that does not change. You're going to be using the equation delta Y equals 1/2 AGT squared to solve for the time, because you got 2 times to take into account. 1, the time here to calculate the horizontal velocity of the ball. That's delta X divided by time. That's part 1 of the experiment. Part 2 is when the ball falls and flies as a projectile. You want to figure out what the delta X is, because I'm going to place this little container here and I'm going to see if I can predict where it's going to land. So that's kind of the game plan. Okay. Alrighty guys, part 2. So I've already done my calculations. I'm not giving you my answers. You need to get your answers. But now I went ahead and put the 2-meter sticks there. It just makes the ball roll in a straight line. That way it doesn't go all over the place. Based on my calculations, I'm expecting the ball to land in here. Now, of course, you need to do your own personal math to figure out what it is. All right, so let me see. Let's see how good I was. Now, it's always easier when you have 2 people, at least collecting data and running at the same time. I did collect and go. Let's see. Let me try one more time. It looked pretty close, but it'd be even better if it would hit my little bucket. So it was a little out, right? Something was a little...
Yeah, it was a little towards you.
Let's see.
Awesome. On the money.
There you go. So I accurately predicted where the ball was going to land.
I sure hope so. You're a physics teacher.
Got it right. All right. So, but that was the first one. Now I'm going to go ahead and do the same thing, but I'm going to change the angle. This one we did at 15 degrees. All right. So you can see right here on the shark fin. For the next ones, all I'm going to do is collect the data, and then you'll be able to calculate the rest of it. All right. All right. Part 3. Now I'm going to go over to my shark fin. I'm going to go ahead and drop it down. Now I have 5-degree angle. Okay. We decided to go down instead of up because the higher up, the faster it goes and the more bounces, and chances are of it not being in a straight line and being a little bit more off. So here we go. So same thing, taking the time once it hits the ground and it keeps rolling. On, up. So this one, here's your new time. 1.25 seconds. All right, here we go, second run. All right, here we go, new time, 1.26 seconds. Third run. One point each other. Alright, I don't like that one because the other two were really close. So I'm gonna go ahead and throw out this trial and go for another one. So don't even use that one as trial 3. We're gonna try it again. There you go. And it's okay to do that because if you get something that's just really, really out there and it's really off, you can go ahead and exchange it. All right, so those are the trial runs for your second run. This was at 5 degrees. All right, we're gonna go ahead and go slightly higher. I know we went lower last time. Am I at 20 degrees?
Yes.
Okay, so we're gonna do it 20 degrees. As I pick up my shark fin and we're at a higher angle, hopefully you're thinking it's gonna run a lot faster, and that's what's gonna happen. So we gotta be better with our reaction time. So here we go. All right, so there's your time. Thank you. Here you go, second run.
Oh,
All right, that one bounced.
not counting that one?
No, let's not count that one. Let's do it again.
Mm-hmm.
There you go. Trial 2.
So the time is acting like we expected. As you increased the angle, obviously you're increasing the speed, so you're shortening the time.
And last trial run. Can you at least introduce yourself, mysterious voice?
Boo.
There you go. All right, now you have all the data to complete your lab. All right, so hopefully y'all are able to make the predictions. I really wish you were in class so we could actually run it and see if it lands exactly where we're at, but unfortunately we're not. But good luck. If you have any questions, please send me a message through Schoology. Bye, y'all.